Okay, in this video, I want to talk about phase transitions. So what is a phase transition? So a phase transition is when matter changes between solid form and liquid form and gaseous form. Okay, that's kind of an analogy that that someone came up with. So the person that came up with it was a guy named Jean Fortenay, and he wrote the book, the XBRL book, which I highly recommend. And he also wrote this white paper on describing the notion of a cell store. And it's in that paper that he came up with the metaphor or the analogy of XBRL facts transitioning between the different states of matter: gas for efficient storage, solid for efficient retrieval, and liquid for efficient interaction with business users. So I see it a little bit different than that, but it's an analogy or a metaphor. Doesn't matter if it's perfect. So I want to show you some things about the gas, liquid, and solid states of a report, so you get an idea. I'm going to go through a couple different ways. So first, I'm going to look at the Microsoft 10K financial report, which is a large report, and I use the same report, 2017. And here you see a fact. You see the entity registrant name. This is a screenshot of the instance document, and this is kind of like the facts free floating in space, but not really. This is a syntax representation. So it's just a list of facts, a flat list of facts. But a better representation of the information in a financial report is using what I believe is called a sparse hypercube. So here's what I mean. So the Microsoft 10K has 2,235 facts. Those are the things that are in the different rows of this screenshot. And it's long. It's not the entire list, but there are also 46 different dimensions. That's what you see in the columns. So you notice by looking at this, you see a bunch of sort of white space, and you see a bunch of kind of darker colors. And basically, where you see white, there is no value, and where you see darker colors, there are values. So by sparse, it means that there's a bunch of empty spaces in this hypercube. And keep that in the back of your mind. You'll understand why this is important in a bit. So zooming in on this a little bit, you can start to see a little better what I'm talking about. So here you have a smaller view. You can see basically the rows, which are facts, and the dimensions, which are columns. And if I take this and I trim it down even more, now I'm only looking at one concept. The concept sales revenue net. There are 64 facts that use the concept US GAAP sales revenues net. Again, you can see that there's a lot of white space, and there are some that have the dimensions. So, why is that? What's going on? So what's going on is this sparse hypercube is defined in the XBRL specification, XBRL dimension specification. It's basically a Cartesian product of all of the facts and all the dimensions. And I'm not going to go into that, but basically, again, notice that it's jagged. So here's another view of a fact. So again, you can see here, this application, it sees all 235 facts. This is a syntax view of the facts. Here's the Microsoft Corporation, entity, registrant name, Microsoft. That's what we saw in the first instance document screenshot. So again, zooming in here now, you can see those were all previously gaseous type representations. So now you can see something happening. You see, number one, that you have fewer facts, and it's less jagged. It's actually not jagged at all. So the unit and the roundings are not dimensions. They're properties of the fact value. So the facts themselves are a rectangle. There's a value for every one of these dimensions. Okay, and here you have one network, and in that network you have one table, statement table, and you have these facts. Okay, so I'm going to change the concept because that concept was only in one place. So this concept, sales revenue net, is in the income statement, and notice it's not a sparse hypercube. Okay, it's a rectangle. And notice the number of dimensions that you have. Okay, so that also same concept exists in this network. Accounting policies, additional information, and this table. Again, notice that it is a rectangle. Again, these are properties of numeric facts. These are non-numeric facts. Okay, here it is again in a different network and table. And again, and again, and again, and again. Okay, let me go back one. So what I'm pointing out is that every one of these different structures has the facts that it needs, and they're being pulled in by some features of XBRL, and you can use the same fact in different sets of facts, fact sets, and that's what is meant by, I view it as the liquid form. You take the gaseous facts and you put them into a container. In the container, all the facts have the same shape. So then you take additional information and you can turn the liquid into a solid, which is basically a rendering of the information. So again, you move from, so there's another solid. So these are three different different renderings that use the same concept: sales, revenue, net. They call it revenues. Got to label revenues in these three structures. So I'm going to show you how you transition from the gaseous state to the liquid state to the solid state. Okay, that will help you understand the advantages of each of these different states, or these different phases. Okay, so again, this is actually, and I won't go into that. So gaseous states, facts act like a gas. They're free floating in space. So this kind of exemplifies that. You have some facts. Okay, the liquid form, you take some of those facts. This was the entire set of facts in this instance. I'm not using the Microsoft document anymore. I'm using a different, smaller filing. So you move from this larger set of all the facts to this smaller set of the facts that you want. So you're putting the facts you want into a container, into a set. Then you use information from the XBRL presentation relations, the XBRL dimension relations, and the rules, and you solidify the liquid and you create a rendering. Okay? So I want to walk you through how you do this. So here is a screenshot of the information I'm working with in an XBRL taxonomy tool. This is just the list of elements, report elements, and labels for the elements. There's no relations. These are just terms. Okay, no associations. In XBRL, you have 3 different types of associations. You have XBRL presentation relations, you have XBRL calculation relations, and definition relations. So you can use that information. So how is it useful? So first, it tells you what concepts you use, what facts to grab based on the concept that is being used by the fact. It also tells you the numeric relations between, the mathematical relations between facts. You can use this information, and here are the facts and other knowledge to transition from gaseous form to liquid form to solid form. So the information you need is you need formatting information. Those are preferences. You use common knowledge about how to render something. So for example, a single underscore for subtotals, a double underscore for grand totals, and then you have information patterns so you know what they're supposed to look like when you solidify them onto a human readable report. A roll up looks different than a roll forward, which looks different from an adjustment, which looks different from a variance. So most software treats these same patterns the same way, and then the renderings are nonsensical to business users. That's unnecessary. So here is the target objective. We want to turn the facts into this rendering, and this is a common format. Any accountant understands this. It's a simple roll-up. It's kind of a small little statement of income. So how do we create this from the gaseous form? So here's our starting point: a set of facts. We've already taken the total facts, and we've weeded out the ones that we want using the XBRL presentation relations and the definition relations, and we have this fact set that we want to work with. So how do we turn this fact table into a rendered report? Okay. What information we have to work with? Okay, we know we're working with the comprehensive income hypercube. We know what elements go into that hypercube from the XBRL presentation relations and the definition relations. We have labels information, sequencing information in the XBRL. We know that this is a roll-up pattern because we can tell from the XBRL calculation relations that it's a roll-up. And we have 2 dimensions in space to work with. We have rows, columns, and cells. Okay? So a roll-up, an important distinction is to know which pattern you're working with. And these are the different patterns of mathematical computations that you can work with. I'm not going to go into the detail, but we are using the roll-up pattern. And so we'll format this per a roll-up pattern. So when you're thinking about this, think pivot table, because we're using those ideas to do the rendering. So I wish that an Excel pivot table would render this stuff correctly, but it doesn't. Excel pivot tables are OLAP based. They try to aggregate things that shouldn't be aggregated. There's no sequencing information, it's better at using numeric values. It doesn't do string values well at all. But one day I predict that Excel will have a multi-dimensional pivot table that does not force you to use OLAP, and that will work with XBRL based information. Okay, so thinking pivot table, the first thing we want to do is we want to identify the slicers. So you notice that these two columns have the same values. That's what we mean by slicer. If it has the same value, then it doesn't do anything to have it down here with this other information. Let's move it up on top. So we identify that, we move it up on top, and we have different information. So now notice that we have two periods. There's a pattern, 2020, 2019. We want to identify which periods, and we want to put the periods in a different spot. And then we want to move the values that go with each period in the proper location. Then we want to get rid of the other rows and columns, and now we have something that looks like this. So then we want to, what did I do? We want to resequence the information using the XBRL presentation relation. So these are actually in the right order. And we want to scale the numbers. So here they're in thousands. We want to take the zeros out and say that it's in thousands. And we want to format the information using the rules about a grand total, having a double underscore. And you can see that we've created something that is very readable by humans by leveraging the features of XBRL plus the common formatting rules plus metadata and patterns that helps you understand what the target you're trying to create is. And this is a commercial product that does all this today. You can look at this. There's all kinds of other interesting things you can do in terms of clicking on the concept and seeing the details of which report element and the properties of that report element, etc. So again, this is about computer algorithms generating the rendering, not humans. I believe that people will realize that inline XBRL is a waste of time eventually, because you can get those same renderings if you leverage the metadata of the information that you're working with. Inline XBRL is just more work. And what I showed you works for I showed you roll up, but it works for roll forwards, adjustments, variants, complex computations. And it'll work for any structure. The Microsoft has 194 different structures, and each one of these is rendered correctly. And you can have different preferences for colors, underlining, fonts, whatever. You could render it as Word, PDF, HTML, Excel type pivot tables. If you can do it for one thing, you can do it for any other format. Anyway, I'll call that good.